Let's consider the transport system you'd find in lower organisms. Okay, we'll also consider that of the higher organisms. We'll look at the transport system of the fish, the amphibians, and of course higher mammals. So starting with the lower organisms, you would wonder, how does the amoeba circulate nutrients within its cell? So let's consider a unicellular organism, like let's say the amoeba, formless shapeless amoeba. So what happens? How does circulation happen within the amoeba? So what happens is that the amoeba, when it moves, okay, it moves, the cytoplasm moves forward. This movement of the cytoplasm helps to transport nutrients, and within this cavity, within the not cavity within the cell. Okay, now what about organisms that doesn't move the cytoplasm? Something like, let's say, the paramecium. Okay, in the paramecium, what happens is that the cytoplasm is constantly in a circular movement. It's in continuous circular movement within the cytoplasm, within the cell. Okay, so that movement of the cytoplasm will help distribute nutrients within the cell. Multicellular organism, like let's say the hydra. How the hydra, let's say this a crude drawing of the hydra. What happens is that the hydra lets in water. Okay, water comes in this way. As water comes in into the gut of the hydra, the water will help transport and move nutrients and oxygen inside the gut of the hydra. Moreover, the hydra also has cells that are flagellated within the gut. So the whip-like movement of these flagellated cells will also aid in moving nutrients and the water that is being let in. Okay, also help in moving it. Then what about higher and something like, let's say, a more complex one, like let's say the flatworm. Okay, the flatworm. Normally the flatworm has a large surface area to volume. Okay, and then the guts of the flatworm is widely distributed. Okay, it's widely extensively channeled. So this aids in distributing nutrients within the body of the flatworm. So let's look at something higher, something like the insect. How does the circulatory system of the insect work? So I'm going to open, okay, this crude drawing of the insect. Here, this place here is the aorta. Then these are chambers, or these are heart chambers. The heart chambers are plenty in the insect, and they extend throughout the body of the insect. Now the heart chambers too also contain muscles. Okay, now there are slit-like openings here, slit-like openings in the heart. On the soft, on these points that I'm pointing out, there are slit-like openings there. Then there's this cavity that exists here, this cavity. Okay, this cavity is known as the hemocele. All right, so what happens is that in the insect, the muscle in the heart chambers contract. When these muscles contract, these slit-like openings will close. Okay, this will force the blood from this lower part here to force it towards the head, towards the aorta. So the blood comes out from here and then enters the hemocele. All right, and then it moves in this fashion backward. Moves backward. Okay, now the hemocele has slit-like partitions. There are thin partitions, very thin partitions within the hemocele that prevents this blood from going back in this direction. So this does not occur. Okay, the blood cannot go back in this direction because of the slit-like the thin partitions within the hemocele. So as the blood flows this way, down, it gets to this dorsal part, this end part, and then it goes back into this heart chamber, and then this whole process of contracting and pushing the blood to the aorta reoccurs, and then the blood goes this same direction, again. The whole process, it goes this way, this way, this way, this way, this way. All right, now the blood does not contain oxygen. You must note that this heart, the heart of an insect, the whole circulatory system of the insect is not designed to also transport oxygen. The insect has special oxygen tubes, okay, O2 tubes, a system of tubes that brings oxygen into the insect, that delivers oxygen that the insect needs. What this blood transports are nutrients. The blood transports nutrients and also carries waste to the malphigian tubule. So because this blood does not transport oxygen, the blood lacks hemoglobin, so the blood is not red, the blood is totally colorless. Now let's compare the circulatory systems that you find in higher invertebrates. Okay, here we go. Okay, here we're going to consider one by one these drawings that I made here. Okay, in the vertebrates, the first one here is the fish. Then this one here is that of the amphibian, and then this one is that of the mammal. Okay, what happens in that of the fish? The fish, if you look at this, is the heart of the fish. Okay, we're looking at the heart, and we're going to consider the circulation, how the whole circulatory process that occurs in these different levels of animals. Okay, in the fish has only one ventricle. I'm going to label the ventricle as V. Okay, then has also one atrium. All right, so blood comes from the body. Here I have BODY from the body. So the blood comes from the body, it goes to the atrium, into the atrium. All right, then from the atrium, there are valves here. There are valves that prevent blood flow back. So it goes into the ventricle, then the ventricle pumps the blood to the gills. All right, GILLS. In case my handwriting is a bit confusing, GILLS. So it pumps it, it goes to the gills. It's at the gills that gaseous exchange take place. Okay, the oxygen goes into the blood, and then the blood carbon dioxide is diffused out, is taken out. All this happens in the gills. Okay, and then from the gills, the oxygenated blood now goes to the body. Okay, then the whole process repeats itself. Now this method here of circulation is known as single circulation, because the blood goes into the heart only once. Now let's consider how does it pan out? When you want to compare it, how does it look if you're comparing that of a fish with an amphibian? What the amphibian has is right atrium, which I'm going to label RA. Also has the left atrium, the LA, and one ventricle. Okay, you see the amphibian is a little bit higher than the fish. At least it has double H, it has two atria. Okay, so what happens here is that blood from the body, okay, there's the body I'm writing, this body of the amphibian here. So blood from the body goes in, okay, into the right atrium. This blood that is going into the right atrium from the body has already delivered oxygen, so it's not oxygenated. Okay, it's not oxygenated at all. Now this blood that goes into the right atrium comes here from this place, goes to the ventricle. Okay, now the blood is also taken to the lungs. It's taken to the lungs. Then from the lungs is oxygenated, goes into the left atrium, and then goes into the ventricle, and from the ventricle to the body. All right, But in reptiles, there is a slight partition of the ventricles, very slight from here, it's not complete, slight, okay, partition of the ventricle. That's the difference in the heart of the amphibian and that of the of the amphibian, in the amphibian and that of the reptile, I'm sorry. So in complete double circulation, you'd find complete double circulation in the heart of a mammal. So the body, I'll put it as B, okay, the body of a mammal, what happens is blood goes in here into the right atrium, the RA. The right atrium, the blood that goes in here is deoxygenated. The oxygen has been removed. It has already delivered the oxygen from the body, okay? So it's now returning to the heart, into the right atrium. All right? Now the blood from the right atrium comes out this way, okay? Okay? And then goes to the lungs. All right? It goes to the lungs. Now this is the pulmonary artery. In the mammal, that's where you find the pulmonary artery carrying deoxygenate. That is the only place where you find an artery carrying deoxygenated blood. All right, it goes to the lung here, or rather I should call this L. Let's call it L. To the lungs, okay, through the pulmonary artery will carry deoxygenated blood. Note, deoxygenated blood. Now the blood is oxygenated in the lungs, and then it comes back, all right, into the left atrium. This is pulmonary vein. Through the pulmonary vein, it's only here in the mammal, this is the only place where you find a vein carrying oxygenated blood. Normally veins carry deoxygenated blood, while the artery will carry oxygenated, but in this case it's reversed. This pulmonary vein is carrying oxygenated blood from the lungs, okay? Now the lungs, this oxygenated blood from this place goes up here, okay, into the left ventricle. Note, this is the right ventricle. Goes into the left ventricle. The left ventricle is highly muscular, is kind of bigger. It is the biggest, more muscular and bigger than all the other chambers of the heart. So what happens here in the left ventricle now takes the blood to the aorta, okay? No, sorry, this is the aorta. The blood comes out from the left ventricle through the aorta and then goes to the body to deliver the oxygen that it has received from the lungs. Now this is a double circulation because you can see the blood goes in twice through the heart, not once as you would find in the fish, not once but twice. You see, you can see this here, then you have this here, okay? I hope this basically introduces you or kind of explains the basic things you need to know about vertebrate circulation.